Welcome to the special edition of the Uptime Wind Energy Podcast. I'm your host, Alan Hall, and I'm here with my co-host, Joel Saxum. If you were an owner, operator, or technician in wind, you have come across pitch bearing problems. And those pitch bearing problems can get really hard to detect early, but once you see them, they're expensive to repair. So Joel and I thought it was time to bring on an expert in bearings to the podcast. So our guest today is Corey Metleiter of Malloy Wind. And Corey has an extensive background in wind bearings. Now, Malloy, if you're not familiar, is based in Sioux Falls, South Dakota, which is in the middle of the United States. And Malloy Wind specializes in providing solutions for wind turbine applications. So they're a total wind-focused organization. They offer a variety of services, including upgraded gearbox bearings, blade bearings, main shaft bearings, pitch motor renewals, and generator bearings. Corey, welcome to the program.
Hey, guys. Thanks for having me.
So there's so many questions about pitch bearings. And just having been down in San Diego at the ACP, OM&S, yeah, one of the complaints is, I got a huge bearing replacement program going on this summer. And my first thought was of you, thinking, wow, you guys must be really busy because bearings are probably after lightning. It's lightning and then bearings were 1 and 2 of the problems for wind turbines at the moment.
Yeah, it's been a busy couple of years. There's certainly standout platforms that are having their own platform-specific failure modes that we're discovering as we work with operators.
Yeah, we talked a little bit off air about some of that thing. Like, okay, so we're in lightning space. We know if someone calls and says, I have this turbine with these blades, you go, ooh, you got problems, right? So I know that it's the same thing in the bearing world. Generators, like you kind of know the ones that are going to happen. So when you guys initially talk with someone, what are some of the points that you ask them right away? Okay, they've called. What are we looking at?
Sure. So to your point, it's a lot of platform specific. We know platform X has this history of problems. Platform Y has a different set of history. And platform Z is a pretty stable, pretty robust platform, for example. So we start to investigate, is it one of those platforms that we already know has some issues that we either maybe have something developed for or are currently working on. We talk about how soon are they experiencing their first failures or how are they detecting them? And most importantly, I think, is how long do they plan to run the site? Are they 2/3 of the way through the life of the site? Then, we probably propose a different solution to them than we do to some of the worst case scenarios where they're having failures in the 3-year ballpark and they're trying to get to 25.
Yeah, no, and one of the things that we talked about was, hey, you're on platform A with bearings, but you have bearings B and C, same design, but different manufacturers, and sometimes you run into issues there as well.
Yeah, it's really interesting when it comes down to it. There's only 4 parts in a blade bearing. There's the rings, the rollers, the seals, and the cage or the spacers, depending on the configuration. It sounds easy, right? But there are a lot of process controls, quality checks, things like that can be done to ensure the best long life operation. We actually got a call about 3 years ago from an operator in our neighborhood that said, we have platform A, and we have 2 bearing manufacturers installed across our fleet, all from original build. The site was about 10 years old. They said, why are all of brand, X failing and none of brand Y? So we worked with them. We investigated that a little bit, and we found exactly that the bearings are the same dimensions, from a raceway load capacity point of view, they should have been the same, right? But what we found is it was some subtle manufacturing differences from the way the raceways were hardened in a process control point of view, and corrosion protection of the bolt holes, for example, that were leading to that. So very small details, right, that lead to larger implications a decade later.
And just seeing some of the pictures that Malloy Wind has on its website, and there's some great technical information about bearings. So if you want to know anything about bearings, go to the Malloy Wind's website and start looking at the technical explanation, because it's written in English in simple terms that even I can understand.
For me.
Yeah, for people like me that don't know a lot about bearings, like that was really helpful because I'm a picture person, right? I want to see how these things break down. The pictures of these pitch bearings coming apart was fascinating because essentially, for what I could tell, it starts to degrade internally and it starts to blow out the seal. So it starts spitting out metal parts that once that begins, it's bad stuff. You really can't fix it from there. If that's my understanding of it.
Right. Yeah, and maybe I'll dive into that, right? So, yeah, to your point, and you mentioned right at the top that blade bearings are almost impossible to get a health assessment on. It's not like a high-speed gearbox bearing where you've got vibration and temperature because it's running fast and at full revolutions. Blade bearings they don't ever go full revolution, and they go so incredibly slow. So you really can't apply any of the traditional bearing monitoring tools that we're used to, right? So health assessment is incredibly difficult. Even so, when you look at the construction of the traditional 2-row 4-point bearing type that's used as a blade bearing, it actually stops you for the most part from even trying to bore scope them.
But you can't access them by design, yeah.
Yeah, you really can't access it. So to your point, Alan, a lot of the times what leads people to look at them or operators to look at them is pitch faults. For example, especially electric pitch turbines, you'll start to see an increase in pitch faults, asymmetry type stuff, or overload, overcurrent on electric pitch. Or I think you mentioned the seals come out and grease leaks all over. You'll get dirty blade ruts, and it's a signal you can see from further away that you may have some blade bearing health issues. So what we do, we support in the field. We don't climb. We don't do the installation or removal. But as the bearing distributors, the bearing experts supporting these operators, we'll get pictures from the field. We'll get a call. What am I looking at if they're not used to navigating that kind of external inspection? We help that way. But when we get, say, a new platform with a new failure mode we haven't heard of, we'll have them replace it. We bring it back to our shop in Sioux Falls, South Dakota, and we'll dismantle it. And I think there's a couple of those dismantling pictures on the website that you talked about. It's kind of a terrible job. It's dirty. That grease is really sticky, especially electric pitch turbines. That the open gear grease is really sticky stuff. But you work through it, you dismantle it. Sometimes they've been locked up such that we had to cut the bearing in half to get inside to see it. Other times we're able to remove the filling plugs, pull the balls out, and rotate the inner ring around, and that still takes half a day to do. So it's a really dirty process. Then you got to clean everything after you get it dismantled. But then we put all that diligence and effort into inspecting the rolling elements that came out, inspecting the raceway, looking for signs of wear or ellipse truncation or what they call micropitting or spalling of the raceways, things like that help inform the updated designs that we are offering to operators that have had these premature failure problems.
One thing you talked about offshore, this is just kind of a funny note. When you were talking about in extreme cases, we're like, how do they know when it fails? Or when does the seal go bad? When does it get enough holes? And you're like, yeah, sometimes you have water that runs into the hub from the outside, or you got to make sure you got your hard hat on when you get out of the truck, because you might have pieces of bearing falling down from the top.
Right. So to that point, one of the common problems in the last 5 or 8 years has been cage failures. And I'll emphasize this by saying none of the failures I'm talking about are I'll say, design failures in terms of, usually when you talk about bearings, the design life is based on rolling contact fatigue, right? The raceway fatigue. All these premature failures are other failure modes. It's the real world. It's the environment. It's things like that. So in the last several years, it's been cage failures has been a big topic, which is internal. That cage will start to rub and tear up. It'll get overrolled by the rolling elements. It'll get sharpened and start to tear up that seal and evacuate and cut up that seal, and that's where the grease comes out. Eventually, that cage can degrade so much that the balls begin to bunch together because there's so much gap opened by the cage that's missing, that's no longer there. So I've seen some where all the cage was gone from the blade side row, for example, and only about half left in the hub side row because there are 2 rows. And if I remember right, it was about 40 to 50 degrees because the balls were all bunched together. 40 to 50 degrees, didn't have any balls. So Joel, to your point then, right, you can see straight through it. And on my shop floor, that's easy, right? You can see the blue rag underneath. But I have heard techs tell me that, they'll be out in a hub, and they'll see all kinds of water is ingressed, or one just last week at OMS told me that he was in a hub, and it was dark. I don't know if it was night or what was going on, but he looked and he saw starlight through the gap. Where balls, cage, and seal all should be blocking your view of that. Just gone.
Yeah. So as we're recording this, I have on my other screen here some of their technical resources. Go to MalloyWind.com, and it has a bunch of tabs on there, but one of them is resources, and I'm looking at technical things. So I'm looking at the ones that says blade bearing cage failures. And there's pictures here that literally, I mean, it looks like a pineapple grenade. Like, it's just fragments, sharp fragments, right? They look like they would, if you touch them, they would just cut your hand up. And there's tons of them.
I want to talk about grease for a minute, because from my experience working on car engines and all kinds of rolling products, airplanes, what you grease these bearings with is really critical to lifetime. Is that part of the magic here? Not only just the way that the bearings are built and some of the hardening and the coatings, but is the grease and proper maintenance there part of keeping the bearing to have a longer life?
Absolutely, right. So grease, I kind of like to view it as grease already is a compromise. It's just a carrier for oil. Oil is what you need, the lubricant that separates from the soap and gets between the balls and raceways. So definitely lubricant health is important in all bearing applications. In blade bearings specifically, because the whole bearing is turning end over end during operation, that ball can move up and down the raceway or move kind of micro movements right around the raceway. So the additives in the blade bearing grease does support avoiding things like false Brinelling. So that can be important there. But yes, the frequent relubrication cycle, some turbines, it's put a bunch in at a 6-month interval, walk away and come back. Other turbine models have auto lubricators, which maintain a more consistent level of grease in that bearing. So both options do exist. And to your point, Alan, on the electric pitch turbines that use an electric motor and a pitch driver, a gearbox with a spur gear on it, they have teeth cut into the bearing. Most of them, it's on the inner ring, but there are a couple turbines, electric pitch, that use a geared outer ring. That needs grease too, right? That needs a lubricant in place to support that, so you don't end up with metal-to-metal contact and rubbing and wear on gear teeth. We actually have seen that in some turbines that didn't have as diligent grease applied to the gear teeth during operation as well.
Is there a certain kind of grease that you recommend, or is it seasonality, right? Do you put a different grease in when it's going to be cold if you're in those kind of climates versus when it's hot?
Or is it specific to a manufacturer? Yeah.
No, because you can't really purge the grease, right? It's just, so you couldn't switch it in that scenario. But largely, we typically, as the bearing supplier, we don't really change the grease. We use what the OEM specified. But to your point, we do know that some turbines have an Arctic package, which may have a different grease than the either tropical or standard package that's applied to the turbine. So that can influence what grease is put in the blade bearings.
So then the failure mode for if it's not grease and lubrication, the other failure mode, which I picked up from your website, was the sort of the stresses on the bearing, where you take this big, strong metal bearing and you shape it like a potato chip. So you're putting this incredible stresses on those rings and on the rollers. I assume that's built into the design, though, right? I mean, are they made to handle those stresses, or is it something about the way it's installed or the blade or how it's operated that creates those stresses?
With wind, we often talk about, say, design loads is a topic of conversation. I kind of view it as air is invisible. They probably had a pretty good idea, but there's who knows what we don't know, right? Whether it's shear, turbulence. There's probably some unknowns going on in these applications. Is how I like to view it. What we do know is there's deformation, to your point, right? We do know from the failures we've done, from the extra analytics that our manufacturing partners have done with their FEA tools. We do know that there's deformation going on. Everybody we talk to pretty well acknowledges that, yes, it's deforming. And what you'll see when you look at that tech articles thing on our website is that one of the other failure modes, to your point, Alan, is ring cracking. That one's a little. It's not a new problem. We've seen ring cracking in wind probably a decade ago already, but the prevalence is increasing. So it's been a much more active topic. It's happening on younger turbines, so it's been a lot more active conversation for us.
Would you tie that younger turbines to larger turbines, right? We're talking, if you're talking older turbines, you're 6-8 ton blades, and now you're getting 10, 12, 15 ton blades. Is that why you're seeing more?
Sure. So, I mean, that's how I view it too. When we look at the blade bearings support a moment load, right? So it's forced at a distance. And when you look at the center pressure from an aerodynamic load, the center pressure is further out on a longer blade. And when you look at just strictly the weight of the blade, the center of mass is further out. So at the same time as the aerodynamic load is getting higher, the weight and the bending moment from the gravity load is getting higher. So one of the diagrams I know I have in those tech articles is we kind of simplify it into two different load sets, the aerodynamic load and the gravity bending moment load, just from the way we present it on the website. Obviously, the FEA tools can consider everything in a very much the more complex application that it is. But both of those have gone up at the same time. So really, and then at the same time, the blade bearing diameter has gone from maybe 1.9 meters to 2.5 meters. So it's only grown by 2 feet, 600 meters approximately, because that's how you support a moment load, right? A larger diameter would reduce that applied load to the raceways. So definitely attributed to that. We've seen when we talk about ring cracking in the younger turbines, it really seems like once we broke about 100 meter rotor diameter is where that conversation has picked up for us in the last 4 or 5 years, like I say.
The immediate thought that came to my mind was we talk with quite a few people in Brazil, and their average megawatt size down there is 3.
For new installations?
Yeah, just the average fleets, because their fleet is so young. So they've only installed a lot of brand new, bigger turbines. They don't have a lot of 20-year-old, 15-year-old turbines on it. So I'm thinking to myself, like, man, the bearing issues they must have down there, it's going to be fleet wide.
To the point from earlier, manufacturer A or B does have a reputation for certain failure modes, right? We know, we kind of know those. And to that point, we because of our tech articles, both on our website and what we shared on LinkedIn, we have talked with operators in South America, South Africa, actually a couple different places in Europe. We've been able to set up some teams meetings and share, some of the investigation that we've done to help inform them where to look, how to start addressing it, both on turbine models that we know that are global turbine models, but also on some that we don't know that aren't installed in the U.S., but they just happen to be, similar failure modes, right?
So this is the important thing I wanted to get to here with Malloy Wind and the awesome place you guys fill in the market. So we know that when you buy a turbine, you get whatever the OEM built for blade bearings, pitch bearings, yaw bearings, whatever that may be. That's what you get. Malloy fills the space where if that fails, or if you need new ones, if you're doing a repower, if you have some kind of issue, you guys are the experts and you have feedback mechanisms built in. So like earlier in the call or earlier in the chat here, we were talking about you guys going and diving into the problem, getting that problem bearing or representative problem bearing of a fleet or whatever it may be back at your shop, tearing it down. But then you guys go the next step further to provide value to the industry. Can you walk us through that?
Yeah, so that process, so we work really closely with one particular manufacturing partner, IMO, based out of Germany. They know a lot from the analytics side, from the manufacturing side, and then also some feedback they've had from field failures education globally. But our role in the U.S. here is to work with those operators and collect that empirical data, right? The teardowns, even the real world stuff. And the nice thing about working with them has been that we can use the baseline knowledge that they had from 30 years of history, little 30 years of history in wind and blade bearings for them, and inform that. And we take this basic part number that we've known from a serial production point of view, and add on to that, right? We've added, for example, 2 years ago, we took a blade bearing that was designed about 20 years ago for an older turbine model, and we've taken all the best practices of a 2021, 2022 wind turbine blade bearing and applied it to that. It's improved sealing, it's corrosion protection, it's different raceway hardening practices, orders of operations in manufacturing processes that weren't known back then, but we're applying all this field education to the new product. So that's kind of what that looks like.
I love that.
That's how the rest of the industry should work.
That's why Malloy exists, right? Because it's hard to find somebody who knows enough about bearings to then incorporate design changes into the next generation so you don't have those problems. There's not a lot of Corys around. That's just why we want to have you on the podcast. From the Malloy Wind standpoint, you're then really changing the industry, right? In the sense that you have an OEM product, it's pretty good, starts to fail, and operators want to upgrade or put something on them that's going to last. That's why they're coming to you. That's a big change for the industry, right? I mean, it just makes the wind industry more resilient in the long run, and that's where we need to go. And as Joel's pointed out many times, there's a lot of companies that are in the wind industry that don't do that service, don't provide that actionable information. And when you run across one, it's so remarkable because you just want to hold them up and say, look here, this is the way it should happen. Look at Malloy Wind. Here we go.
That's interesting. I started at Malloy almost 15 years ago now, and I started supporting other industries, and that's how we support all of the industries across our company. As we look at it, and we not just say, hey, there's a part number, we can offer you that part number. We like to ask why, I guess is what I like to say. Why are you replacing it, right? So that's, I guess I kind of cut my teeth doing that, learning from our shop and to our other industries. And I've just applied the same approach as we discover problems with our wind customers too.
Yeah, I mean, at the end of the day, a bearing is a wear part. Now, it's a very long life wear part, right? It's not like the brakes on your car where you're like, yeah, that's going to go now. They should last a long time, but they do wear down, right? Especially in industrial applications. But you guys, so let's talk about this then. When customers come to you, are they usually, hey, we're repowering? Or is it like, man, we've got a fleet-wide issue, we need to solve it? What do you think that split is?
Yes, so repower projects aren't as active in the aftermarket, I think. So a lot of the repowers are done with OEMs, right? So you're using those turnkey OEM designs that we kind of talked about already. There are some repowers, I like to call them overhauls, where you're starting, I like to describe, you start on the low speed side because that's the big stuff, that's the heavy stuff, it's stuff that takes the big crane, right? You start at the blades, the hub, and work backwards. So on those overhaul projects, we are able to help offer something that I'll say we learn of the history on that platform and apply this 2024 current generation wind blade bearing technology to make sure that they meet their goals. On the other hand, there are some turbines that are, to your point, Joel, younger, 3, 4, 5 years. They maybe had their first failure in blade bearings 2.5, 3 years. They're really striving to hit the 20. And some of these newer sites, right, that we're talking 25, maybe 30 year is the desirable time horizon to operate those sites. And if an application, doesn't matter what the application is, if a blade bearing failed in 3 years, that's a big problem, and you kind of need an impactful solution to try and get another 22 years out of that, for example, right?
Otherwise, we'll be replacing them every 3 years.
Yeah. So we have some bigger solutions for that big of a problem. And then other ones, like the one I mentioned a minute ago, they made it to 10 years. Maybe they'll try and hit 20, and maybe they'll try and coast a little past 20, get a little gravy on the end, right? But let's do, so we have a little bit of different tools we can apply. We have, we can do a little bit better. We can update the design by that 10, 15 years, the corrosion protection, the bolt holes, larger balls, maybe, things like this. We can still use the same basic bearing type. We don't need to make this big overhaul change like we do. So that's why we ask the questions we ask early on. What's your failure rate? How old is the site? And what is your time horizon? So we can try and apply the right tool to help them meet their goals.
Malloy Wind is a big resource, and people should get onto your website and check out all the information you have there. How do people get a hold of Malloy Wind, and how do they get a hold of you if they have bearing issues?
I've always got my email on, just about like any of us, right? So I definitely have my email address, which is cmitlighter@malloyelectric.com, because our wind division is a part of our bigger company, Malloy Electric. Wind@Malloy Electric, much easier to spell, is a good one. We have a shared inbox, shared amongst the inside team here, or message me on LinkedIn, like Alan, you did recently. So yeah, LinkedIn, website, email, phone is my direct line is 605-357-1076.
There you go. So if you have bearing issues, better give Corey a call. All right, Corey, thank you so much for being on the program. Joel and I have learned a tremendous amount.
Thanks, guys.